So the next concept we're going to learn is about the specific charge. Now, what is specific charge? Specific charge is the ratio of charge to mass. That means if you take the charge divided by the mass, it's called specific charge of any particle. So why do you want to find the specific charge? Now, specific charge is very important. There are two things that we use it for. Number one, it acts like a identification for which element that you are using in your sample, because every element, they will have a unique value of specific charge. It's something like a thumbprint for humans. It's unique for each element. Example, if you look at potassium and sodium, they will both have the same charge. But because they have different masses, so if you take the charge and divide by the mass, you get different values. So this is the principle we use in a mass spectrometer. I think in chemistry you have learned about the mass spectrometer, where they put in a sample and then they find the composition of the sample, what kind of elements are present. So that is using your specific charge as an identification. Now, another thing they can also use is they can actually use the charge divided by the specific charge, and you will actually end up with the mass of the particle. So that means you can determine the charge, you can determine the specific charge. So when you divide, you get the mass. Example will be electron. How did they find out the mass of electron? Is by using the Millikan's Ore-Drug experiment to find the charge, and then later on using one of the experiments we'll show today to find your specific charge and divide to get the mass of the electron. So what is the significance of specific charge? The bigger the specific charge, the easier to manipulate it using electric or magnetic fields. That means the higher specific charge will accelerate the greatest in the electric field, it will bend the most in the magnetic field, so it's easiest to manipulate, which is why last time when they had TVs and all that, they used electrons and the cathode ray tube, because electrons had the higher specific charge, it was easiest to manipulate. So there are many ways or many methods to determine specific charge. So we're not going to examine every single way. We're going to look at one of the method, but the principle is the same. The principle is you have to make use of the three cases that we learned in the previous video about, remember, in the uniform electric field, it accelerates, then it's half m squared equals to qv, or w equals to qv. If it moves in a circle in a magnetic field, then it's fb equals to bqv, which is equals to fc, so you get bqv equals to mv squared over r. If it is in a uniform magnetic and electric field, and it moves or it travels straight through undeflected, then we will use the Fe equals Fb, the velocity selector. So you use any of these three formulas depending on the situation. Okay, so we're going to use this mass spectrometer as an example. Now, imagine we want to use this specific charge to determine, the technique how to determine specific charge using a mass spectrometer. So what will happen is, let's say we have ion source here, and you have many different ions, different elements, and they enter collimator slits, and the collimator slits are just to ensure that they're traveling straight through. And when it enters this region, can you see uniform electric fields and magnetic field here? And it passes straight through undeflected. So which equation do we use in this case? Fb equals to Fe, right? So assuming that the magnetic field here we call B1, because there are two magnetic fields here and here, so let's call this B1 and B2 So this will be B1 QV equals to EQ okay, so you can cancel the Q, so you get the equation for V equals to E over B1. Now we usually we will make the V as a subject, because we're going to get rid of V later, because it's the speed that's difficult to determine. So now it will enter a region of uniform magnetic field, and can you see it moves in a circle? So what equation do we use? Fb equals to Fc, which is BQV equals to mv squared over r. So cancel one of the V, so V equals to B. Oh yeah, I forgot to tell you just now. Remember we said we want to use B2 because it's a second field. So B2QR over M. So since both of these equations are in terms of V, what we can do is we can combine them together. So if by combining both these equations, okay, what will I get? So I will get E over B1 equals to B2QR over M. So my specific charge, which is Q over M, therefore will give me E over B1, B2, R. So you will notice that different elements with different specific charge, alright, will end up with different values of radius. So that means it will hit the photographic film at different positions. So when they hit at different positions, the computer will see the R and then will determine the specific charge. Example. So this will be the image that you obtain. Example of the image that you obtain. So when the photographic film shows you different lines, right? So the computer can calculate the radius or measure the radius and deduce what is a specific charge. Then from the specific charge can tell you what elements are present. So if they are darker lines, means there are more of the elements. So they will even tell you the percentage of each element. So this is an example of finding the specific charge.